Hello, this is MSD Group 22888, and this is just a brief overview of our Finger Lakes Explorer ROV. Starting from the left, I'm Zach Talmadge, a fifth-year mechanical engineering major. Next to me is Jared Kammer, a fifth-year mechanical engineer. Next to him is Jake Halpern, another fifth-year mechanical engineer. Next to him is Sean Davis, a fifth-year electrical engineering major. Next to him is Shu Kang, another fifth-year electrical engineer. And lastly, Kyle Kirk, a fourth-year mechanical engineering major. Our supporting faculty on this project is Mark Manuni, our project advisor, and Dr. Jason Kologi, our advisor, and also our client for this project.
With the introduction out of the way, what actually is FLARE? FLARE is an underwater remotely operated vehicle, or ROV, designed to explore the Finger Lakes of New York. It's basically an underwater drone. The project was initially conceived by Dr. Jason Kologi, who's a longtime diving enthusiast who was looking for a different way to explore Conesus Lake, which is the closest Finger Lake to Rochester. By operating remotely, FLARE enables easier studying of the Finger Lakes or other underwater environments at depths and durations that are difficult for a human to reach.
As for some of the defining features and characteristics of our Flare ROV, we have an HD camera that streams video to a controller and a laptop on the surface. There's a 100-foot tether cable that connects the ROV to that same laptop and controller, and this is where user input and data is transferred through. Our engineering requirement was to be able to dive to at least 100 feet underwater, but with extra room in our budget, we were actually able to over design for this requirement, and we can go to 900 feet underwater. We also have multi-axis steering and propulsion, as well as self-leveling features.
After several months of concept generation and model revisions, our team arrived at this vehicle design. It can be separated into three main components. First is the chassis. It's an aluminum frame which rigidly connects all of the other components together. Its A-frame shape keeps the vehicle's center of gravity low and its center of volume high. This, along with the buoyant foam on top, means that the ROV will float and remain oriented upright in the water. The second main component is the central tube. This watertight enclosure protects the electronics to depths of up to 300 meters. Its clear acrylic dome allows the camera to get a clear image while remaining dry. Finally, there's the propulsion system. We chose to use 6 thrusters, 1 in each corner and 2 in the center aimed vertically. This configuration gives the vehicle great freedom of movement while remaining intuitive and controllable for the pilot.
Our biggest challenge when designing our ROV was keeping the internal components dry. The rear of our ROV has holes where cords from the external components can interface with the internal components. If water creeps in between our connection point, it's game over. To prevent this from occurring, we've applied sealant to waterproof our entry ports. With proper care and meticulous inspection, we can mitigate any risk and any chance of water getting inside of our ROV.
The core of our RV operation is the EduSAR software. This software enables communication between the RV and our surface computer. The connection between these two devices is established through a 100-feet tether cable. Commands data are transmitted from the computer to the RV via the tether cable to direct its movement. Control of the RV is achieved using an X-bar controller connected to the surface computer. This familiar game controller simplifies the operation, making it accessible and user-friendly for all operators.
For the end goal of Flare, we want to make it an easy-to-use device with similar functionality to other commercially available alternatives, similar to the Blue Robotics ROV2, for example. So we want to have high-quality video and onboard lighting so you can see what's under the water, especially at lower depths. It's very hard to see what you're looking at, so having proper lighting can make it much easier to see what's there under the Finger Lakes. We want to also make the ROV easy to transport. So we want to have a surface controller box and an ROV and have those be able to be taken to and from the place and not have to bring much more than any of that. Just a simple, small amount of equipment. We also want to make it easy to use. We want to make it controlled with a laptop and a game controller, fairly easy to get equipment without needing to have to spend hours figuring out how it works, reading manuals, or being trained. We also want a long battery life. One of our intentions for the ROV is to make sure that it can stay underwater for at least 30 minutes and still record, and be able to return to the surface after those 30 minutes. So we can actually get a sufficient amount of data, and we don't want it to break. It needs to be durable, it needs to be strong, and we don't want water getting in, we don't want it to fall apart, and we don't want it to catch fire. So anything that can take a bit more of a beating, anything that can be transported without breaking, you don't want to use it and be afraid that it's not going to survive the adventure.
Thank you for listening to our brief overview of our Flare ROV.